Hello, math humans. We're going to do 1.6a today. We're going to be talking about parent functions. Our objectives are that we're going to introduce and analyze the 8 parent functions, and our analyzing is going to cover domain, range, extrema, even and odd, symmetry, and then increasing and decreasing. So let's just jump right in. Our first parent function is called the identity function. The equation is y is equal to x, that's an x, and the graph looks like this. It goes through the origin, and then that would be our handy dandy graph. And so we're going to analyze each function. So our domain is negative infinity to positive infinity, all real numbers because nothing's undefined. The range is going to be the same thing, negative infinity to positive infinity. For this particular function, get a different colored pen so it's easier to see, it has a positive slope over the whole function. So we can say that this particular function increases over the domain. Now I have to make sure that I've defined the domain first, but this one increases over the domain. For the extrema, this one has none. You can't leave it blank if you are analyzing a function on a test. You have to tell me that it has none. For this particular function, I'm just going to write SYMM for symmetry. It is symmetric about the origin, and then therefore this is an odd function. All right, for our next function, we're going to do the squaring function. And then there are 8, and this is y is equal to x squared. Scoot me up a little bit. My graph is going to look, it's just a cute little parabola. I'm going to add some information to it before we move on. This side of the graph is decreasing, and this side of the graph is increasing. My domain is all real numbers. Remember, I can report either in interval notation or as this funny looking R. My range is going to be from 0 to positive infinity. This particular function is going to decrease from a negative infinity to 0, and then it's going to increase from 0 to positive infinity. I think if you add the little slope arrows at the beginning, it helps with your increasing and decreasing. For the extrema, it has an absolute minimum at x is equal to 0, so I guess it would have been handy if I told you that point was 0. The symmetry is about the y-axis, therefore it is an even function. All right, moving on, number 3. This is going to be the cubing function. It's kind of handy that my numbers are lining up so politely. And so this is y is equal to x cubed. Okay, we know this function, but we're just going to add his graph because it's easier to assess things as we look. This guy has an increasing slope, and this guy has an increasing slope. The domain, all real numbers. The range is also all real numbers because there's nothing that makes this function undefined. It is increasing over the domain. Okay. Extrema, it has none. There are no maximums or minimums. The symmetry is about the origin. Therefore, this is an odd function. All right, 3 down, 5 to go. So the next one that we want to talk about is the square root function. And that is y is equal to the square root of x. And notice that we're only talking about the principal root. And the principal root is the positive root. We're not going to talk about plus or minus because then that technically is not a function. So the square root function looks like this. It's the top half of the curve. And if we talk about its slope, he is increasing. So then my domain is it starts at 0 and goes to positive infinity. My range also starts at 0 and goes to positive infinity. This particular function is increasing over the domain. For the extrema, it has an absolute minimum at x is equal to 0. I keep forgetting to put that little guy on there. For the symmetry, it actually has none because it's not symmetric about the y-axis, nor is it symmetric about the origin because there's nothing over here. And then since it has no symmetry, it is neither even or odd. Okay? All right, this particular graph has another unique feature. You can't, well, you can. Graphically, you can't take the square root of a negative number. So this particular function is undefined for x is less than 0. I can take the square root of 0, so it's defined at x is equal to 0, but I can't take the square root of a negative number and have that show up on my graph. Next function, function number 5, is going to be our rational function. And this one has some cool extra features as well. And this is going to be y is equal to 1 over x. We've talked about rational functions before. Technically, it's a function divided by a function. It just so happens that the function in the numerator is a constant. When I graph this guy, it has a vertical asymptote. So I'm just going to write it here at x is equal to 0. And it has a horizontal asymptote at y is equal to 0. And again, that full discussion is coming later. And the branches are in the first and the third quadrants. Okay? So then as I fill in the rest of the information, the domain is from a negative infinity to 0. And then it starts again on the other side and goes to positive infinity. So this would tell you that you have a vertical asymptote because it's undefined at 0. The range is going to be the same thing. It's going to be a negative infinity to 0, and then it's going to start again on the other side of 0 and go to positive infinity. We talked about the slope. This guy is going down, and this guy is going down. Therefore, this particular function is decreasing over the domain. And then for extrema, it has none. It has no maxes or mins. Symmetry, it's symmetric about the origin, and then therefore this is an odd function. Whew, almost done. Here's function number 6. It is the absolute value graph, which is a glorious little graph, which technically is a piecewise function, but we can talk about that more later. The graph looks like this. It's like a parabola, except it has a sharp point. We talked about the slope. This side of the graph is negative. My bad, you can't see that. And this side of the slope is positive. Sorry, of the graph is positive. The domain is all real numbers. There's nothing that makes the graph undefined. The range, it starts at 0 and goes to positive infinity. Sorry, I had to get my calculator out of the way. It was doing weird things. It is decreasing from a negative infinity to 0. There's that silly little 0 again. And then it is increasing from 0 to positive infinity. For the extrema, it has an absolute minimum at x is equal to 0. For the symmetry, it is symmetric about the y-axis. Therefore, this is an even function. So a lot of times people think that even means that it has to have an even power, but this is an even function, and it has no power. It's an absolute value, so that's kind of an interesting concept. You need to make sure that you understand that an even function is symmetric about the y-axis. Okay? I will tell you now, this is technically a piecewise function, and in calculus we have to talk about it as a piecewise, otherwise it causes some issues, which we don't need to know about now, but this is another way of writing the absolute value function. Instead of writing it as the absolute value, I can write it like this, which is a piecewise. So that's kind of cool information. All right, we are almost done. So now we're up to graph number 7. This is a cool graph. It's called the logistic function, and we will spend more time on this later in the year. But the basic graph is 1 over 1 plus e to the negative x. This is a really unique graph in that it has some features that other graphs don't have. This particular graph has 2 horizontal asymptotes. So it has 2 horizontal asymptotes. Okay. The top of the function is called the carrying capacity, or we sometimes call it a limit to growth. So you see this often in science applications when we're talking about how big can a population get. And one of the examples that we will talk about in my class is how big can the population of Flagstaff get? Well, it depends on a lot of things. So for right now, the domain of this is all real numbers. The x values are defined for all real numbers. The range, this is, we're going to call this guy a -1 and a +1. The range is going to be a -1 to a +1. Not included because they have horizontal asymptotes. This particular graph has a positive slope, so it is increasing over the domain. And remember, you can't say it's something over the domain unless you have already defined the domain. We've talked about its 2 horizontal asymptotes for extrema. Technically, it has none. It has an absolute max that it's trying to get to, but it's never quite going to make it. And it has an absolute min that it's going to try to get to, but it's never going to quite make it. So we really would say that the extrema are none. For the symmetry, it's also going to be none, although it looks like it's symmetric about the origin because it's been shifted up a little bit, therefore it's not symmetric about the origin. And since it has no symmetry, it is neither even nor odd. All right, our last function is the only one that I'm actually going to show you in your calculator because it's kind of cool. It's called the greatest integer function. And the equation is weird, so it's this kind of funky looking little bracket, and it's called the greatest integer. And I'm not going to spend a lot of time on it because even in calculus we don't spend a ton of time, but the way it looks is kind of like this. And then you have this graph with all of these technically vertical asymptotes along the graph. Let me show you what it looks like if you put it in your grapher. So I'm going to go to my y equals, and I'm going to do math number, maybe, can I find it? Maybe I can find it, and maybe not. Sad day. I can't remember now where it is. Probability. Well, I have no idea. Maybe I'm just an airhead. Let's see. Log. Well, there you go. Oh, there it is. It's option number 5. My bad. So I'm going to put x. So that's the greatest integer function. And I'm going to do a zoom 6. And it looks like little stair steps. That's kind of cool. Okay, see if I can get my thingy to focus. Alright, so that's kind of a cool thing. That's the greatest integer function. We'll talk about it a little bit, but that would be how you put it in your calculator, and then we're not going to do much with it for the rest of the year. Alrighty, my math humans, that is it for today. Lucky you. I will see you tomorrow.